5, 4, 3, 2, 1.
Alright, so now we turn to looking at applications of recursive formulae. We've done the basics to introduce APs and GPs, and now it's time to apply them to some real-life problems. Example 1 is about crochet, which is a kind of knitting. And we're told that on the first row we begin with 1 stitch, then we end up with 3 stitches on the second row, and so on. And the pattern is that we're adding 2 stitches to each row to build up that shape. So this, of course, is a simple arithmetic progression. There's a common difference of 2. Now, sometimes it is helpful just to draw up a table of values with n and tn. When we do this, you can see it's the same idea as a table of x and y values, where x equals 1, x equals 2, and so on, and tn is equivalent to y. And if we actually graph that, you get a straight line, which is true for all arithmetic progressions. So sometimes it's useful to set up a table like that. The recursive rule we can write as the next term equals the previous term plus 2, where the first term is 1. There is an alternative way to write these rules that enable us to jump straight to a value. And the general pattern is Tn equals A, which is the first term, plus n minus 1 in brackets times D, which is of course the common difference. So we can put the values in from this example, A equals 1 and D equals 2, and we can rearrange that to give Tn equals 2n minus 1. So the question asks us how many stitches will be in the 35th row. Well, you can use your ClassPad and either the spreadsheet or the sequence app to work it out, and you'll get T35 equals 69. Using the direct approach to jump to the value, you can just substitute 35 for n and multiply that through, subtract the 1, and you get 69. Example 2 is the first of our financial applications. $400 is invested in an account and earns $20 interest each year. How much is the account worth after 1 year, 2 years, 3 years, and 10 years? So we can write a rule for this. The next term is equal to the previous term plus $20. We're adding $20 interest each year, so it's pretty straightforward. The trick with this one is to know that T0 equals 400. It's not T1 that equals 400. T1 corresponds to the amount after 1 year, which would be $420. So if you're using ClassPad, make sure you choose the AN plus 1 and A0 option and enter A0 as 400. You can calculate this using your ClassPad and you will get these values. Now we're going to review percentage change. When working on geometric progression questions, we often deal with percentage increases and decreases. When a quantity is increased, the original amount is taken as 100% and the increase is added to that 100%. So to increase $850 by 15%, we add 15%, making a total of 115% of the original amount. Then we write that percentage as a decimal, which is 1.15, and then we can calculate our answer. Similarly, for decreasing a quantity, the original amount is taken as 100%, and then we subtract the decrease. So in example 2, to decrease $850 by 15%, it's the amount minus 15%, which equals 85% of the amount. Once again, we change that to a decimal and write it as 0.85 multiplied by 850 will give us the answer. In example 3, the population of Anne's ant farm is increasing by 9% per month. If the initial population is 300 ants, we need to find the population after 1 month and after 6 months. Alright, so this is a percentage increase question, and what we're aiming to do here is find the rate of increase. So I'm jumping straight to the answer. The rate is 1.09. Effectively, that's just 100% plus another 9% written as a decimal. This, of course, is a geometric progression because the amount is being increased by a fixed ratio each month, and that ratio is 1.09. So we can write the progression as Tn plus 1 equals 1.09 times Tn, where the initial amount, T0, is 300. Once again, the initial amount is not T1, which is the amount after 1 month. So again, with your ClassPad, make sure you enter the correct parameters. And after 1 month, you'll see that the answer is 327, and after 6 months, 503. You can always do a simple calculation to check that you're right if you are relying on your ClassPad. 1.09 times 300 equals 327, which is very easy to find.